So hello everyone, welcome back to my YouTube channel hansda Education. In today's video I am going to discuss about a very interesting topic of basic organic chemistry, and that is nothing but the degree of unsaturation. So let's start the video. So here it is the degree of unsaturation, and these are the other names that are used for the same. So let's see them one by one. So degree of unsaturation, or DU, or we can say that hydrogen deficiency index, or HDI. We can also say that index of hydrogen deficiency, or IHD. The same is also known as unsaturation index, or UI, or it is also known as the double bond equivalent, or DBE. These are the other names that are used for the degree of unsaturation. So in different books you will find different names, so don't confuse with these names. They basically are the same things. So let us first of all understand what is unsaturation. So organic compounds are basically of two types. They are saturated and unsaturated. So saturated organic compound means the organic compound containing carbon-carbon single bond. So one example is alkane, whose general formula is CnH2n plus 2. And the unsaturated compound means the organic compound containing a pi bond or a ring. So it may contain a double bond or triple bond, or it may contain a cycle or a ring. The examples are alkene, whose general formula is CnH2n, alkyne, whose general formula is CnH2n minus 2, and the compound containing a ring or cycle. So the unsaturated compounds are basically the compound containing either pi bond or a ring, or both of them. So let's see a compound whose molecular formula is C2H6 and its corresponding structural formula is CH3 single bond CH3. So let I remove 2 hydrogen from this compound. So it will be C2H4 and its corresponding corresponding structural formula will be CH2 double bond CH2. So there will be a double bond. That means whenever I am removing 2 hydrogen from a saturated compound, then double bond appears. So double bond appears in a molecule because of the deficiency in hydrogen. So whenever there is deficiency in hydrogen, then double bond appears in that compound. So here is the C2H6 and the structural formula is CH3 single bond CH3, and this compound is saturated. So let's say I removed 2 hydrogen from this compound. So it will be now C2H4, whose structural formula will be CH2 double bond CH2. So there will be one double bond as I remove 2 hydrogen from this saturated compound. So when I again remove 2 hydrogen from this, it will be C2H2, whose structural formula will be CH triple bond CH. So there will be 2 pi bond, and its degree of unsaturation is 1 and its degree of unsaturation is 2. So whenever I am removing hydrogen from a saturated compound, then it will get converted into unsaturated compound. So whenever there is deficiency in hydrogen atom, it introduces unsaturation in the compound. The unsaturation means either pi bond or a ring, or both of them. Here is the compound C2H4, and I add 1 mole of hydrogen, so it get converted into C2H6. So it was unsaturated and it is now saturated. So the definition of DU says that the number of mole of H2 that must be supplied to convert a molecule into upon-chain saturated compound. So du is nothing but the total number of moles of hydrogen that must be supplied to convert a given unsaturated compound into upon-chain saturated compound. This is the definition of du. So let's say an example, the compound is C2H2. So when we add 1 mole H2, it gets converted into C2H4, and when we add 1 mole H2, then again it convert into C2H6. Now it is a saturated compound. So in order to convert this C2H2 into a upon-chain saturated compound, we require 2 mole of hydrogen. So its du will be 2. So now let us understand what is double bond equivalent. So let's say I have a molecular formula C3H6. So this can be either a compound like this, or this also can be a compound like this. So same molecular formula represents two different structures. So whenever there is a double bond, there can be a ring like this also. So you can say that ring is possible with the same molecular formula where double bond is also possible. So whenever there is the possibility of a multiple bond, then there is also the possibility of a ring. So ring is known as the double bond equivalent. So let's see the method to calculate the degree of unsaturation. So here is the method. So it is basically of two type. When the structure is given and when the molecular formula is given. When the structure is given, in that case the degree of unsaturation is equal to total number of pi bonds present in that compound plus total number of individual or independent rings present in that compound. It is nothing but the total number of pi bonds plus total number of individual or independent rings. By individual or independent rings, we mean that the ring inside which no other ring is present. This type of ring we have to count. There is another definition of degree of unsaturation, and that is the minimum number of bonds that must be broken to convert a given compound into upon-chain saturated compound. This definition is basically applicable for the compound of cyclic form. It says that minimum number of bonds that must be broken to convert a compound into upon-chain saturated compound. So here is another method. When the molecular formula is given, in that case degree of unsaturation, that is du, will be equal to C plus 1 minus H plus X minus N upon 2, where C is the number of carbon atom present in that compound, H is the number of hydrogen atom, X is the number of halogen atoms, and N is the number of nitrogen atoms. So the formula is C plus 1 minus H plus X minus N upon 2. Here one thing we have to note, that the atoms like oxygen, sulfur, that is the oxygen family members, or divalent atoms are not considered for du calculation. They are neglected. So you have to see only the carbon, hydrogen, halogen and nitrogen, and you have to apply this formula to find out the du of a given compound. So I am repeating it again. This is the method of calculation of du. So when structure is given, just you have to find out total number of pi bonds plus total number of individual or independent rings. When molecular formula is given, du will be C plus 1 minus H plus X minus N upon 2, where C is the number of carbon atoms, H is the number of hydrogen atoms, X is the number of halogen atoms, N is the number of nitrogen atoms. And oxygen, sulfur like atom are not considered for du calculation. They are neglected. So here is some example for du calculation. So these are here is a compound C3H7N. So here the number of carbon is 3, number of hydrogen is 7, number of nitrogen is 1. So Du will be C plus 1 minus H plus X minus N upon 2. So number of carbon is 3, 3 plus 1 minus number of hydrogen 7 plus no halogen minus 1 nitrogen upon 2. So that will be 1. Similarly for this compound C5H8NClO, number of carbon atom 5, number of hydrogen atom 8, number of nitrogen 1, number of chlorine atom 1, number of oxygen 1. So Du will be C plus 1 minus H plus X minus N by 2. So that will be 5 plus 1 minus 8 plus 1 minus 1 by 2, that will be 2. Please note that oxygen atom is neglected for Du calculation. So for the compound like C2H6, number of carbon is 2, number of hydrogen is 6. So Du will be C plus 1 minus H plus X minus N upon 2. So that will be 0. So the compounds like this cubene, this is a cubene or this is the cyclic compound. For this type of compound, your Du will be number of bonds to be broken to convert into a unsaturated compound. So this compound contains 6 rings. So its Du should be 6, but it is nothing. So if we break 5 bonds, then it will get converted into a unsaturated compound. So its Du will be 5. So this is the basic definition, and the basic definition says that the minimum number of bonds that should be broken to convert a given compound into a unsaturated compound. If we break 5 bonds of this compound, then it will get converted into a unsaturated compound. For this type of compound, Du is equal to number of phase minus 1. So this compound has 6 phase minus 1, that will be 5. So Du is equal to 5. For there is another compound which is prismine. It has number of phase is equal to 5. So Du will be n minus 1 is equal to 5 minus 1 will be 4. So here is a compound and we want to find out its Du. So Du will be pi bond plus ring. So here it is 1, 2, 3, 4 pi bonds and number of ring is 1, 2, 3. So 4 plus 3 will be 7. Please note that we have to count only the individual rings or independent rings. We do not have to count this kind of the whole ring or the larger rings, because inside this larger ring there is one also smaller rings. So we have to calculate those rings inside who there is no other rings. That means we have to calculate the individual rings. So total number of individual ring is 3 plus total number of pi bond 4. So 4 plus 3 it will be 7. For example, here another compound and it has pi bond equal to 1 and 2. So 2 pi bond and the number of ring, this is 1 ring. So 2 plus 1 it will be 3. So let's see what it indicates. From the Du we can predict the structural formula, or we can determine the total number of structural isomers, etc. These are the use of Du. We can determine the total number of structural isomers, or we can predict the structural formula of that compound. So if the Du of a given compound is negative, that means it indicates that the compound does not exist. For example, C4H14O. If the Du of a given compound is 0, that means the compound contains no bond or no ring. That means the compound will be unsaturated compound. If the compound Du is 1, that means the compound contains either one ring or one pi bond. If the Du is equal to 2, then the compound contains 2 ring or 2 pi bond or 1 ring and 1 pi bond. So 2 pi bond means it can be either 2 double bond or 1 triple bond. So from the Du calculation we can predict the structural formula of that compound, or we can also predict the number of structural isomers, etc. So this is very important. So we should understand it very carefully. So thank you.